Have you ever looked up at the sky and seen a thunderstorm brewing? The clouds darken, the wind picks up, and the air becomes charged with anticipation. Suddenly, a flash of lightning splits the sky, illuminating the dark clouds for a brief, electrifying moment. This is followed by a booming clap of thunder that reverberates through the air, shaking the ground beneath your feet. Thunderstorms are one of nature's most dramatic displays of power, a captivating blend of light, sound, and raw energy. They remind us of the immense forces at play in the atmosphere above us, forces that can be both beautiful and terrifying. But what causes these awe-inspiring events? How do these powerful storms form? Thunderstorms are complex weather phenomena, involving a series of intricate processes. However, their basic ingredients are relatively simple: warm, moist air, and unstable atmospheric conditions. When these elements combine, the stage is set for a spectacular meteorological performance, one that can be both mesmerizing and dangerous. In this exploration of thunderstorms, we'll delve into the science behind these storms, examining the conditions that lead to their formation. We'll uncover the factors that drive their formation, from the initial buildup of clouds to the explosive release of energy. We'll also explore the dynamics of lightning and thunder, understanding how these phenomena occur and their impact on the environment. And we'll look at the different types of thunderstorms that can arise, each with its own unique characteristics and behaviors. Join us as we unlock the secrets of these meteorological marvels, gaining insights from experts and storm chasers alike. Together, we'll gain a deeper appreciation for the raw power and captivating beauty of thunderstorms and the science that makes them possible. The formation of a thunderstorm is a fascinating process that begins with the interplay of warmth, moisture, and rising air. It all starts with the sun's energy heating the Earth's surface. As the ground warms, it heats the air directly above it. Warm air is lighter and less dense than cold air, so it begins to rise, like a hot air balloon. This rising air is known as an updraft. If the air is humid, meaning it contains a lot of moisture, the rising air will cool and condense as it ascends. As the water vapor in the air cools, it changes from an invisible gas to tiny water droplets or ice crystals, forming clouds. Temperature and moisture are the essential ingredients in the recipe for a thunderstorm. The warmer the air, the more moisture it can hold. Think of a sponge. A dry sponge can only absorb a small amount of water, but a damp sponge can soak up much more. Similarly, warm air acts like a damp sponge, capable of holding a large amount of water vapor. When this warm, moisture-laden air rises, it cools and the water vapor condenses, forming clouds and releasing even more heat. This release of heat further fuels the updraft, creating a powerful cycle of rising air, condensation, and heat release that drives the growth of the thunderstorm. As a thunderstorm develops, it's characterized by a continuous dance between updrafts and downdrafts, columns of rising and descending air that shape the storm's structure. The updraft, as we've learned, is the engine of the storm, pulling warm, moist air upwards. As the air rises and cools, condensation forms clouds and releases heat, further fueling the updraft. However, as the cloud droplets and ice crystals in the updraft grow larger and heavier, they eventually begin to fall as precipitation. This falling precipitation drags air downwards with it, creating a downdraft. Downdrafts bring cooler, drier air from higher altitudes down towards the Earth's surface. The interplay between updrafts and downdrafts creates the characteristic turbulent winds and heavy precipitation associated with thunderstorms. Section 5. Lightning, nature's electric spark. One of the most captivating and awe-inspiring aspects of a thunderstorm is the lightning. Lightning is a sudden, massive electrostatic discharge that occurs within the storm clouds, between clouds, or between a cloud and the ground. But what causes this dramatic release of electrical energy? The exact mechanisms behind lightning generation are still being studied, but it's believed that the collisions between ice crystals and graupel, which is soft hail, within the storm cloud play a crucial role. These collisions cause a separation of electrical charges within the cloud, with positive charges typically gathering at the top of the cloud and negative charges accumulating in the middle and lower portions of the cloud. When the electrical potential difference between these areas becomes sufficiently large, it overwhelms the insulating capacity of the air and a sudden discharge of electricity. Lightning occurs. Section 6. The The roar of thunder. Sound waves from the sky. The deafening roar of thunder that accompanies lightning is a testament to the immense energy unleashed by this electrical discharge. This energy is so powerful that it can be heard miles away, creating a sense of awe and sometimes fear in those who experience it. Thunder is not caused by the sound of the lightning bolt itself, but rather by the rapid expansion of the air surrounding the lightning channel. This expansion happens in a fraction of a second, creating a shock wave that we perceive as thunder. When lightning occurs, the electrical current passing through the air heats it to incredibly high temperatures, up to 50,000 degrees Fahrenheit, almost instantly. This intense heat causes the air to glow and expand rapidly. This extreme heating causes the air to expand explosively, creating a shock wave that travels outward from the lightning channel at supersonic speeds. The shock wave is so powerful that it can sometimes be felt as a physical force. This shock wave is what we hear as thunder. The sound can vary in intensity, from a sharp crack to a long rolling rumble, depending on the distance and the nature of the lightning strike. The rumbling, rolling sound of thunder is due to the sound waves bouncing off the ground, clouds, and other objects in the atmosphere. These reflections and refractions of sound waves create the characteristic rumble that can last for several seconds. The distance of the lightning strike can be estimated by counting the seconds between the flash of lightning and the sound of thunder. Every 5 seconds represents approximately 1 mile. This simple method allows us to gauge how far away the storm is and prepare accordingly. Section 7. Types of thunderstorms, from single cells to supercells. Thunderstorms come in a variety of shapes and sizes, from relatively short-lived isolated storms known as single-cell thunderstorms. These storms are often the most common type of thunderstorm and can be seen forming on warm, humid days. On the other end of the spectrum, we have massive, long-lasting, and potentially destructive storms called supercells. These are the giants of the thunderstorm world, capable of causing significant damage. Single-cell thunderstorms, as their name suggests, are characterized by a single updraft-downdraft couplet and typically last for 30 to 60 minutes. Despite their short lifespan, they can still pack a punch. They can produce heavy rain, lightning, and gusty winds, but are usually not associated with severe weather. These storms often provide much-needed rain to parched areas without causing significant harm. Multi-cell thunderstorms, on the other hand, consist of multiple thunderstorm cells in various stages of development, often arranged in a line or cluster. This arrangement allows them to last longer and cover a larger area. These storms can last for several hours and can produce more widespread severe weather, including hail, damaging winds, and even tornadoes. Their ability to regenerate new cells makes them particularly dangerous. Supercells are the most powerful and dangerous type of thunderstorm. They are often the culprits behind the most severe weather events we experience. They are characterized by a single rotating updraft known as a mesocyclone. This rotation is what sets them apart from other types of thunderstorms. This rotation allows supercells to maintain themselves for extended periods, sometimes for several hours, and produce a wide range of severe weather, including very large hail, destructive tornadoes, and flash flooding. Their longevity and intensity make them a significant threat to life and property. Section 8. Staying safe during a thunderstorm, precautions and shelter. Thunderstorms, while captivating to observe, can also pose significant risks. Lightning strikes are a leading cause of weather-related fatalities, and even non-severe thunderstorms can produce dangerous lightning. It's crucial to take precautions and seek appropriate shelter when thunderstorms are in the area. Remember the phrase 30-30 rule. If less than 30 seconds pass between a lightning flash and the sound of thunder, the storm is close enough to pose an immediate threat, and you should seek shelter immediately. Safe shelters include sturdy buildings with plumbing and electrical wiring, or hardtop vehicles. Avoid open fields, tall trees, water, and metal objects, as these can attract lightning or provide a path for the electrical current to flow. Stay indoors for at least 30 minutes after the last clap of thunder before resuming outdoor activities. Section 9. Conclusion. Awe-inspiring power, unpredictable beauty. Thunderstorms are a captivating reminder of the raw power and unpredictable beauty of the natural world. They are complex meteorological events driven by the interplay of warmth, moisture, and atmospheric instability. From the initial rising thermals to the explosive release of energy in the form of lightning and thunder, Thunderstorms command our attention and inspire a sense of awe. While these storms can be destructive, understanding their dynamics, respecting their power, and taking appropriate safety precautions allows us to appreciate their beauty while minimizing the risks. So the next time you find yourself beneath a stormy sky, take a moment to marvel at the symphony of light, sound, and fury unfolding above you, a testament to the dynamism and wonder of our planet's atmosphere. Subscribe for more interesting facts and stay tuned for our next exploration into the wonders of nature.